So for the part of today, you have MPI. This is done in Linux. And you have the way of sending messages between the nodes that exist inside the network, such that each and every node is characterized by your CPUs. You've also got the memory associated, and then like inside any computer, you've got a bus between them, such that basically, according to the network, you have all these nodes which communicate with one another in a distributed manner. Meaning that you will have for it, everything is written in C, such that you will include the mpi.h, the header file. Then you will have the beginning of the program, meaning that you will have to initialize the environment such that you need to define which is your communication channel, how many processes you've got, being the word rank, as well as you've got your task number, so which is exactly your process number, knowing that you start counting the processes from position number 0. After that, you have the logic behind passing the calls, and in the end, you need to finish your MPI environment, such that you have at the beginning, you include mpi.h, so this is C programming inside a C file. And then you see all these nodes as being spread around the world according to the protocol of MPI-COM1, such that for each and every process, you've got a task ID. Then you can have errors, such that in the end, you need to check that everything finishes with success. So you have MPI success, which is in fact 0. So like in C programming, if you recall, you have that return 0, meaning that everything finishes successfully. Then for initializing, you will have the communication size being a dimension of your total MPI processes, such that when you will want to send a message, you need to specify which is exactly the variable with ampersand of buffer, because you simply allocate the memory for it. You have a dimension, okay, which is this count. You've got a data type, which is, for example, MPI int. You've also got a destination, where destination is in fact your process ID, where you start counting from 0. Then you've got a tag, as well as you've got a communication channel between the nodes. When you want to receive something, you need firstly to have another process which did send that information. And in order to read it, you have the ampersand of your variable. You've got a dimension for it. So being an integer, you have dimension 1. Then you have the MPI data type. After that, you've got the source, meaning which is my process ID for it, okay, as well as a tag, whether you want to associate, which is the channel, and the status. So whenever you have for this status, you have the operation such that you have the source of the message and even the tag for it. So let's see. First of all, for installing it in Ubuntu, you need to have your system up to date. You will have the C programming. So this is why you need to have installed the build minus essential. And then you have the installation of your open MPI, so the environment of the MPI. Or what you can also do is to write sudo apt-get install, and then you have the MPI ch. So I'm going to type it here, MPI ch, to install npk, and you will not go through all these steps, so they will be done for you. Also, it may be needed to do also an upgrade according to your system if you didn't do it a long time ago. So let's see some sample code. I will go through the one which includes more details. So meaning that over here, you will have to firstly include your headers, MPI ch, then you have the standard input output, as well as the standard library in C programming. Then you've got the int main according to the arguments. So keep in mind that everything is inside the C file, after which you need to set the MPI environment. So you will have to set which is the communication channel. For your communication channel, you set a word rank, as well as you've got the word size for it. Then based on word rank, Word rank corresponds to a certain process, meaning that you will start counting from process 0. So keep in mind that you start counting from it. And now you see that whether the word rank is not 0, I want to receive this token, which is of type int. Its dimension is 1. The type is MPI int. And now I need to say, so when I receive, which is my source. So the source will be, in fact, word rank -1, meaning that you want to receive the value of token from the previous process. Also, you've got the tag, so the tag you can neglect it and it can be 0. You've got the communication channel as well as the status. So whether you don't want to use it, you've got the status ignore. What matters most is to have this token, which is simply passed from one process to another. Now, if you want to display the content, you have the printf, so don't forget that you are using C programming, not C++ with C out, C in. It is printf with modulus D, so this will be a number, and because they are int, you put it with modulus D for the process ID, which is in fact the word rank for it. The token is in fact written as token over here. And as well as you've got the process ID, so which is your source, and your source is this one. It is word rank -1. So don't forget that when you want to send and to receive a value using MPI, you have it with ampersand, such that everything is stored inside. Then, whether it is not the case, you can even update the value of the token, as well as you can send the token. So here, it means that you send the token of dimension 1 of type MPI int. Then when sending, you need to specify which is your destination. So your destination will be your following process. But now maybe you are already at the final process, at the last process. So this is why you need to do the modulus of word size. So you need to update, you upgrade the word rank, you add the +1, and now maybe you're just at the end, so you need to start again at the beginning. So this is why you do the modulus of word size. After that, you've got the tag, as well as you have MPI com1. Okay. Then you also have the word rank 0, meaning that you are in the first process. So here you can receive the token of dimension 1 of type MPI int. Then you need to say from whom, from which process do I receive it? Well, it will be the last process. So it is the word size. Keep in mind, word size is the maximum capacity that you can have. And you have the -1, while word rank is exactly the rank of your current process. Then you've got the tag, you've got the communication channel, as well as the status. And again, you want to display that the process based on the ID word rank received a certain token, which is this one, and you receive it from the last process available, which will be the word size -1. And in the end, you need to close everything such that you've got the MPI finalized. Now, everything exists inside a C file, and you want to compile it with MPI CC. And in the end, after compiling it, you get the object file, so you've got it as hello. When you want to test your whole environment, you've got the MPI run with -np of 2. So you set the number of processes to be 2. And then you compile what you receive, so being with / of hello. Okay. Such that here as an exercise, you will have to split the sum and to have it computed by 2 processes, meaning that you can split it into half, and process number 0 will compute the first sum, while process number 2 will compute the second sum, and it will also receive, you can have another process number 3, receiving the sum of both of them. Then you can also have the average. So you have the average such that if you lose precision, if you split your array into 2 and then you combine the average of two halves, such that one process will do the whole sum and division, and then you can pass it through the second process, which can receive it. If you have a matrix and you want to add it in parallel, so let's see how you can do it. Okay, so you've got a matrix. Okay. If you add two matrices, how should they be according to the dimension? Their dimension should be different or equal. So whenever you add two matrices, their dimension should be exactly the same. Okay, so if here I have n lines and m columns, I need to also add it according to a matrix of n lines and m columns. So here, how do you add two matrices? What will you add? You've got this element which gets added by the other one. So according to the same position, you add those elements, meaning that here you can split the matrix or horizontally, or another way of doing it is vertically, okay? As well as you can split it between multiple processes. So you can have here process number 0, process number 1, process number 2, okay, and process number 3. And then you simply do the reunion of all computation. Now, when you think about multiplying it, what matters the most about the dimension? If the first matrix has n lines and m columns, then the second matrix should have what, which is the median dimension to perform the computation. So if here you've got n lines, yes, n lines, and m, see, the controller. Okay, n and m. So with n and m, you multiply by a matrix having m lines, and you can have p columns, meaning that in total, the result matrix will have n lines, and you've got p columns. So here you multiply row by column. You've got this part with this part, and this is how you do it step by step. Okay, so you can divide your computation, and you can split it here into half and this one into another half, such that process number 0 receives this part and this part. So here it's again with process number 0, process number 1, process number 2, process number 3, and while here you've got process number 1 and process number 1. So this is how you can split it and divide it between the two of them, because this is what you have to do for the homework. So here, for the first exercise, you just split the array and to do the sum. The first part of the array is computed by process number 0, the second part by process number 2, and in the end, process number 3 reunites the result. While for process number 2, you've got the multiplication of the two matrices, and you receive exactly, so you will perform exactly these computations by dividing your matrix. I will stop